1948, chassis and the standard 4-cylinder engine. Welcome back to the engine history. A lot of working mechanics have asked the same question. Under a thick skin of rust and decades of seizure, does the engine block still have enough compression to fire again? Today, we are not talking about modern machines full of plastic parts and electronic circuit boards. We are going straight to the core mechanical system of a real block of iron. A Ferguson TEA-20, built in 1948. Looking at this dull gray chassis packed with hardened dirt, many outsiders would call it scrapyard waste. But to mechanics, this is a valuable mechanical foundation. The TEA-20 is not just an ordinary tractor. It is a hinge design that helped trigger the post-World War II agricultural mechanization revolution. Its standard 4-cylinder gasoline engine was cast to plow and endure the harsh fields of Europe. Look at the cooling fins, already eaten by rust. Smell that burnt bite of metal filings mixed with dried, hardened grease. After so many years abandoned in a storage cellar, can we bring back the sharp, hard-edged exhaust note of this engine one more time? Teardown work under the late afternoon sun. The first step is a full evaluation of the engine block in its current condition. Check the oil dipstick. The oil is still there. It is thick and pitch black, but it has not been contaminated by coolant water at all. That is a good sign for the internal top end. But the ignition electrical system is another hard problem. The copper wiring has completely crumbled. The battery ground terminals are coated with green corrosion from oxidized copper. The crew must rewire and fully correct this system before feeding power for ignition. Before we go deeper into opening the carburetor assembly and checking valve clearances inside the combustion chamber of this Ferguson, if you love technical specifications and pure mechanical drivetrains, hit subscribe to the Engine History. Turn on notifications to follow the most classic teardowns and restorations of mechanical power plants. Your support is real motivation that helps the channel keep producing these detailed teardown sequences. The restoration begins with cleaning. Under a high-pressure washer, decades of packed mud and hardened grease are stripped away. The cast markings on the block appear, standard Hotchkiss. Next comes the most complicated stage, the carburetor assembly. This is the core component that meters the air-fuel mixture for the engine. As you remove each retaining screw, you will see internal passages locked solid with grime and copper rust. Every part, from the jet needle and float to the throttle shaft, must be soaked in specialized chemicals to break down deposits. Then, everything is blown clean with extremely high-pressure compressed air. Even a tiny grain of residue left behind is enough to throw off the mixture ratio and make the engine pop and stumble immediately. Firing up and checking oil pressure. After the fuel lines have been flushed clean and the distributor assembly has been set with a feeler gauge to correct the contact gap at the spark plug points, the firing stage begins. The crew drains the sludge, pours in fresh engine oil, and fills it with gasoline mixed with an additive to clean the combustion chamber jets. A high discharge battery is clamped directly to the starter motor. Listen to this sound. The starter gear grinds into the flywheel, turning heavily at first, then building speed. The first ignition hits a misfire. Thick black smoke blasts straight out of the exhaust neck. But that is proof that the combustion chamber still has compression. The mechanic feeds a little priming fuel directly into the intake throat. The spark plug flashes. The 2.0-liter engine shakes violently, then locks into running speed. The exhaust has none of the smooth, muffled tone of modern machinery. It is sharp, decisive, and brutally aggressive. Most impressive of all, the oil pressure gauge needle jumps straight into the safe zone immediately. Unbelievable. A cast iron engine block, nearly 80 years old, and the oil pump still drives pressure that is tight and strong. That is the clearest proof of manufacturing tolerances and material quality from that era. Real load test on dirt ground. Running it idle in place is not enough. This Ferguson engine must pass a real load test. The mechanic reinstalls the air filter housing, inflates the treaded tires to proper pressure, and releases the clutch to roll the machine out of the shop after decades of being trapped. The 4-speed manual gearbox has the stiff, gritty feel typical of old machines. But once the gears are engaged, torque goes down to the rear axle with shocking stubborn pull. With the machine's weight pressing down, the wide tread tires bite into wet ground and keep moving without slipping on slopes or losing breath. Watching the chassis grind forward through muddy ground is when you truly respect the basic design quality. The TEA20 uses no hydraulic power steering at all. It has no modern damping system of any kind. Everything is direct impact from pure mechanics. Every vibration pulse of the crankshaft transmits straight through the frame and into the steering wheel. It forces the operator to use real physical strength to wrestle the wheel. And that delivers a control feeling you cannot mistake, like commanding a living muscle of iron and steel. Mechanical summary. This full restoration of the 1948 Ferguson TEA20 is the clearest hands-on technical proof of the peak manufacturing skill of past century engineers. Their core design confirms one principle: thick cast iron, precise tolerances, and strict lubrication discipline mean even a machine worked to the limit will not die on the road. Thank you for following the engine history through this complete teardown and cleanup job today. If you have worked in the trade, what impression did this rugged tractor design leave on you? Or which technical step impressed you most in the carburetor work? Just know. Leave your analysis in the comments so everyone can learn from it. Wishing you strong health and see you again in the next engine specification teardown.